Okay, back where we left off. Next thing we are going to do, we're gonna add the turn in place animations and change the velocity, sprinting or walking or jogging. So first thing I'm gonna do, I'm going to edit project settings. I'm gonna add inputs. The first input, it's gonna be an action mapping here. Right. Sprint, it's going to be the left shift, and walk is going to be a walk, going to be left alt. So we have this. Now we can close this and head back to our code. I have it open here. One thing we can do is, well, let's create a new input here. If function void input start sprint without any parameters. Same thing for stop. So void input stop sprint. And we add the same for walk. So void input start walk. And your function void input stop walk. So we have this. Now we define this. So we're gonna implement this. I'll implement it down here. So void base character input start sprint void a base character input score stop sprint void a base character input start walk, and the same thing for stop walk. A base character input stop walk, and we'll have this. Now let's bind the input. So I was going to layer inputs component bind action, going to be sprint, the name that we put in the editor. It's going to be, instead of being this here, this bind action actually have 4 parameters, not only just 3 like the bind access. So it's going to be IE pressed, this, and a base character, and the function also bind start sprint. Player inputs component bind action sprint IE released, this, and a base character input stop sprint. And it's going to be basically the same thing for walking. So we put walk here and input start walk and stop walk. The only thing these functions here will do is to change a variable. So the variable is the one in the structure, is like current speed. When it starts sprinting, the current speed will be E, speed state sprinting. When it's not, it's going to be jogging. And the same thing for stop walk will be jogging. And for the input walk will be ESS walking. This will just control these variables. The real calculation will be done in the update character animation struct. That will be like this. We're gonna get the current movement, so current speed gonna be get velocity. Not get velocity, will be get character movement velocity, not velocity, max walk speed. When speed, stand and crouch it. And we will change this accordingly. So it's gonna be get character movement max walk speed equals f math f interp 2. The current is gonna be current based on the if the character is standing, so movement struct dot stance equals to e stance state stand if it's standing, the velocity will be the current speed stand, otherwise it's going to be current speed crouched. Just I have to do this, it can be seen better. The target velocity is going to be the character new stance plus the velocity, like get the velocity. It'll be movement speed, and the stand here is going to be movement structure dot stance current stance, and delta time will be delta time, and next will be, I don't know, 4. Oh, right. Gotta have here the target velocity, so okay, back here. One thing we will add is the new target velocity. But first, let's add something here. We're going to add a new boolean, so const bool. No, not really. F movement speed movement speed equals movement structure dot speed slash the current state. That means it's movement structure dot state current stance as we have it. And here on new target velocity is going to be this, so we have here new variable is speed state we do this as a const movement struct current speed. So here is gonna be based on this. So movement speed, the new target velocity will be based on speed state equals e speed state walking, it's going to be movement speed dot slow, or let me do this differently. So if speed state equals ESS speed state ESS walking, then let's put here float new target velocity 0. New target velocity is going to be movement speed dot slow speed, else if speed state equals speed state jogging is going to be new target velocity equals movement speed dot median, else it's going to be fast. And this is going to be our new character velocity. So get character movement max walk speed, and max walk speed crouched to the new target velocity. Another thing that I want to do here, it's on when we get the rotation of the Alright, I'm back here. Now the last thing I want to do here is I want to modify these values here. So movement, look right axis. What I'm gonna do is I'm gonna normalize the delta rotator of this so I can get the current looking rotation for the character. So it's gonna be UX math library normalize delta rotator. To actually have access to this function, I have to add to this class, I have to add here on helpers include kismat on / kismat math library.h. So I now have access to this. So the first value will be the control rotation, get control rotation, and the second one will be this character rotation. And with this I will have the current rotation of this on the yaw. And this, instead of dot 13, I will have 25 and minus 55, negative 25. With this I'll have the results if we turn right or left. Now if I hit Ctrl B, wait for it to build, I'll be back when it's finished building. Okay, the build is finished. Okay, now if let's test if it's working the run and walk. Here I'm walking, press shift, start jogging, shift again, start running, stop, press and shift, start jogging, press shift and hold, he runs it, press alt and hold, he's going to walk. It's be like this. I always try to be rotated to the control rotation, but they have this smooth transition. And now let's add the turn in place animations. We open this up here on locomotion. On the idle state we're gonna add a conduit. It's going to be turn in place conduit. Back here we're gonna get our structure here, brake. We are going to get this turn left and type R. That means if we are turning left or right, we should do this. Add something more, and we need not to be moving. We can't not be moving when we do this. It would be something like this. Copy this, go to when it's back here, same thing, and here we add not to the values so it's correct. Not, that means if we are not turning and still not moving, we are going to go back in this direction. Now we drag this to the movement and we copy this and paste it here. And now instead of this end node and this not here, all we want to do is if it's moving or it's not turning left and or not turning right, actually this 2 is N and not R. Brake, remove pin. They're going to be if we are not turning left and not turning right, or we are moving, we are going to just continue the movement as we are not turning in place. Now we double click in this, set this posit to true, then we create the states. It's going to be turn left, connect back here, connect another one, turn right, come back here. I'm gonna try to make this a little bit cleaner. Now it's going to be basically the same thing as this. The only difference is we just connect the turn left. And here when we are not turning left, it's basically gonna be like this. Gonna be the same thing for the right. The only thing it will change is the variable right there. And we add our turn animations here. This one is the left, so I will add the turn in place left. And the right one here. If we play, when we turn, he'll turn until he matches the rotation of where the camera is looking. If we start moving, it's supposed to be stopping the animation. It's moving or moving. This I have to change to or moving. It's actually both are or. No, it's not. Okay, the only thing that I need to modify was on the turning place conduit to the movement. I just changed it, that I just put here, if it's moving it's going to finish. No, it's basically that. I start moving, it stops. So that's it for this video. On the next I'll be covering crouching and the same thing that today with turning place and speed. So yeah, see you on the next video.